All right, so here's chapter 8.6 part 2, combinations. It's going to be short and sweet. Mostly we're just going to look at a formula here that you've actually already seen before. So a combination is the number of ways from in objects can be taken r at a time. In other words, basically we're going to say, well, we have in things, okay, and we want to put them into groups of r size. An easy example of this would be I have 30 students and I want to know how many groups of 3 that I could combine those 30 students into. Okay, so we're going to look back, and you should recognize this from the binomial theorem. This is just the choose formula. You have the option of doing it on your calculator, but you do of course need to know how to do it manually as well. Here's the formula. And this formula will actually take care of pretty much all the legwork for us. So n is the number of elements in the set. So again, if we were using that example that I was just talking about, what you would actually do is just say that there are 30 students in the class, and we want to put them into groups of 3, and that would be what R would be the groups of 3. So an example would be how many different combinations of the letters in Doherty are there, taking the numbers or taking the 3 letters at a time. Okay, so basically in this case we need to identify the 2 pieces of information. We need to identify n. Well, n is the number of elements that we have. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So n will equal 9 in this case, and we want them to be in groups of 3. So r is just going to equal 3. So we can then apply our formula, again putting n on the top and r on the bottom. Okay. And we just plug it in, and once you plug it in, it's actually going to spit out that there are a total of 84 possible combinations, which is a lot quicker than sitting here and trying to just use a different method, like for example just listing them all out, which would take a very, very long time. Okay, obviously you'd be listing out 84 different combinations. Okay, so just be familiar with the formula, and in fact, you already get a head start because we already have used this formula when we were working with binomial expansions. So an example like this, it says, in how many ways can a student select 6 courses from 7 electives, okay, and 5, or using 7 electives and 5 core classes if 2 electives and 4 core classes must be taken. Okay, so obviously we definitely are run into a bit of an issue here, and we're going to have to basically take it 2 steps at a time. So first we're going to want to figure out the number of combinations that we could take for the electives. So for the electives, there's a total number of courses. There's 7, and we are only going to be able to pick 2 of them. So that's where the 7 and the 2 come from. Okay, so if we want to figure out the number of combinations of electives we can take, okay, then we're just going to plug them into the formula, and we find that we can take 21 total electives. Now the next piece of the puzzle is to figure out how many core classes we can take. Okay, so for the core classes, I got these values by saying that there are a total of 5 core classes, and I have to take 4 total. So there are a total of 5, and I want to see how many groups of 4 I can pool those up into. And we see that and this is in fact a much smaller number. There's only 5 possible combinations that we could do. Well, we've learned in the past that the basic idea of number theory is that if we have 21 possible outcomes for the first piece, and then we have 5 possible outcomes for the second piece, well, we could combine all of those together, and that will actually give us the total number of possible outcomes. We could basically take these 21, and if we group them up with those 5 other options that we got from our core classes, we would be able to solve the problem. Okay. And as I said, it is nice and it is short and sweet for this lesson. So you are all done. Just make sure that you have the notes basically detailing the couple examples I went over, the combinations theorem, which you should already have, but write it down again, and I will see you at class.